isomers may break the structured isomers, making the compounds that differ in physical properties, else in the chemical properties. And this is in the same thing or in the case of structure isomers or constitutional isomers. Maybe differ in chemical properties only, and slightly differ in physical properties. This is in the case of the optical isomers. For the alkanes only, we will find not constitutional isomers, we will find the only optical isomers. This is slide number 1. Let's explain firstly the constitutional isomers and the cases for the alkane. File. Desktop, I need the desktop. Source chemistry. Okay. For the alkene, single bond, okay, for the alkene, single bond, general rule CN H2N plus 2. Maybe you will find alkane plus O. Alkanes plus O, like this in this examples. Okay, alkane plus O. It's giving to us ether and alcohol. Alkane plus O giving to us maybe ether, may giving to us alcohol. An example like when we find C2, H5 or H6O. This is molecular formula may giving to us C2, H5, OH. This is called the ethanol. May giving to us CH3, O, CH3, dimethyl ether. Dimethyl ether, ethanol and dimethyl ether is different functional group. This is functional group OH.
طب هي
And this
بتدي ده أو ده؟
yes, this is functional group O. So when we find the alkane plus O, it's giving two isomers, alkane, the general rule for it, CN, H2N plus 2. Okay? Maybe you found for the alkene. Alkene plus O, alkene plus O2. Plus O, it's giving to us aldehyde and ketone. Plus O2 giving to us carboxylic acid and ester. Let's take an example. If we'll find the CH3, CH3, C double bond O, CH3. It is the example is acetone or dimethyl ketone. Dimethyl ketone. The functional group in this case, C double bond O, may be giving to us C2 H4 C double bond O H. This is called Miss S propanal. The functional group in this case, it is aldehyde group. Alkene, the general rule for it will be CN H2N only. If we will find the alkene plus O2 like CH3, CH3 for the ester, it will be CH3 COO C2H5. It's called methyl or ethyl acetate ester. The functional group in this case, it will be COO. COO, it is the functional group of the ester. They may making another isomers for this. The isomer of this, it will be COOH, and it's only one H from this, so it will be C3H5 plus 3, it is the 8. 1H, so C3H7. So it's called Miss S butanoic acid. Since when we giving the name, we'll find firstly the COH, the carboxylic group, and when I have this three carbon atom and one carbon atom, it means Miss S propute. 4 carbon atoms, it means butanoic related to the carboxylic acid. So it is the carboxylic acid. But for the alkane again, when they have the same molecular formula, for alkane only, it giving to us in, like take an example, C4H10. This is called Miss S propute, 4 carbon atom butane. It's related to alkane since the CnH2n plus 2. So may giving to us the compound like this. In butane or iso methyl to methyl propane. In butane, it means that C, 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 the side it taking 3H and the mid taking 2H. In the sometimes in the reference we'll find the C taking the shape like this. This taking consideration the angles between the atoms. No problem in this case. Okay, but for this it will be Miss S prop, and this carbon it's called the CH3. So when I'm giving the name for it, it will be 2-methyl 2-methyl Miss S prop propane, or iso Miss S prop butyl isobutyl isobutyl only, since the carbon atom is taking the shape of this case. Maybe we'll find if the carbon atom number of the carbon atoms is increased, it giving to us the tertiary, maybe giving to us new. Tertiary, it means that the central carbon atom surrounded by 4 carbon atoms. New, that means the central atom is the branch, the central carbon again. The tertiary, we'll find that the branch taking the shape of letter T. But for the new, the central atom surrounded by 4 carbon atom taking the shape of letter or the sign plus. As the number of the carbon atoms increase, the molar mass of the compound increase and the boiling point of the compound increase. So we'll find the boiling point of N-butane is greater than 2-methyl propane, although they are the same isomers. Why? When in this case we return to the longest carbon chain, as the number of the carbon atom in the longest carbon chain is increased, the boiling point of the compound is increased. So as the number of the carbon atoms increase in the longest carbon chains, for the isomers, the boiling point is increased. For this compound, 1, 2, 3, 4. 4 in the longest carbon chain. And for this compound in the longest carbon chain is 3. So as the number of the carbon atom, I'm giving it like the note, as number of carbon atoms increases in longest carbon chain, for isomers, the boiling point is increased. Okay, let's back to a type of the isomers for the alkane. It's called the optical isomers. Okay, optical isomers. Optical isomers. Before talking about the optical isomers, we are going to talk about the thing is called chiralic atom. Chiral atom. Chiral atom is related to the Latin language. It means the chiral, it means that the hand. Take an examples for the 2-methyl or 3-methyl hexane, Miss S prop put bent hex. The carbon atom number 3 will find the methyl. We can consider this carbon atom is the chiral. This is the chain minus the hydrogen. I not put the hydrogen. It must saturated with the hydrogen. Okay. Okay. Wait a moment. I will close the door. Then back. Okay. From where I determined that the atom is the chiral atom. Chiral atom, it means that the atom that found in the compound. Chiral atom, it means atom founded in compound surrounded by four different groups. Like this section. For this section, we will find the central atom are surrounded by CH3, by H, by CH2, and CH2. So we can consider this atom is the chiral atom. Right. What is the problem for the chiral atom? If we look to the chiral atom in the mirror, for this compound, if we will put the mirror in the front of this compound, put the mirror. This is line representing the mirror. I'm choosing the. Okay, this compound and this is representing the mirror. What is the range of the atom for the mirror image for this compound? We'll find the carbon atom and else the carbon atom. CH3, its position is change. It will be changing to this side. H. So it will be changed to another side. This is the mirror of the compound. The left it will be right and the right it will be the left. And the C still only 2C. This is the chiral atom and this is carbon and the carbon. We'll find the CH3 in this side are in the right, but in this side are in the left. This is represented the compound and the mirror image. If the compound and the mirror image, this is called the optical isomers. In the case of the optical isomers, like when you put your right hand on the front of the mirror, or when you put right hand in the front of the left hand. On the mirror, they are go over each other. But if we put the right hand over the left hand, the shape are well changes. I will open the camera to can see what I need from you about the object and the mirror shape, or look to this PowerPoint presentations. Bismillah. I'm set the compound and the optical isomer is represented as the compound and its image in the mirror. If we put your hand in the front, your image on the mirror, they will the same. But if we're removing this hand and put it the left hand over the right hand, you will find the position of the fingers are different. Like in the camera that will appear in the front of you now. I will open the camera. Okay, Bismillah. Okay, like this shape. The compound, it will be like this shape. When we put the right hand over the left hand or the left hand on the right hand, the position of the hand will be different. Okay, let's back. what is the change in this case? We'll find for the optical isomers is differ in the deviation of the light, the deviation of the light for the compound, one deviate the light to D and other deviate the light toward L. What's meant that deviate the light toward D? For the D, it deviate the light, make polarize, polarizes light to clockwise direction. It's making the change of the position of the light toward the clockwise. And this deviate the light or polarize light to anti-clock direction. Let's take an example. This is slide number 2.
مستر
Ask your question.
طيب interruption بس الحين مش هتحضر ولا قالت إن هي مش هتعرف تحضر.
Okay, no problem. It will be recorded. It can see it in our team, inshallah.
هي بس كانت بتستأذن حضرتك.
No problem, no problem. It's taken consideration, inshallah. Now we are going to talk about the glucose. D glucose versus L glucose. They all represent the optical isomers. The differ, we'll find the D glucose used in metabolism inside your body, liberate energy. Carbohydrates. Burning inside the body. The body cell. Gives D glucose and L glucose. D glucose is represent the needed by your body cell to liberate the energy. This is get out the body through excretion process. There is no use for this compound. If it is still inside the body, may be changed into fats. Okay. Return back to the glucose structure. Glucose structure, it will be represent O, H, C, 2, 3, 4, 5, and 6. So it will be H, OH, 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 H, H, OH. Maybe in this side it will be OH and H, 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 H. Okay, if we look to the mirror image for this compound, the mirror image for this compound, it will be like this. So it will be C double bond O, H, it will be in this side, all of the H's. and OH in the other side. This slide number 3. OH. OH. This represents the D-glucose that's used to liberate the energy, and the other L for the it's not used by the body. So in the optical isomers, it's used in the medical field. Sometimes it's used inside the carbohydrates or protein inside your body. Sometimes we can find the uses for it. In other times, there is no use for this compound. Okay. Now return back to the sum of the question. It is our topic today. It's only about the isomers. Now we are going to talk about the alkenes, isomers, and the cis and trans. Alkenes. Alkene, the general rule for it will be CnH2n. As we said before in the first slide, maybe alkene plus O, maybe alkene plus O2. It's giving to us aldehyde, ketone. This is giving to us carboxyl group, carboxylic acid, and ester. But for the optical isomers, this is about the constitutional isomers. Of the alkene. But if we talk about the optical isomers, we are going to talk about the cis and trans. Cis and trans represent the opticals or the isomers that differ in the geometrical orientation in the space. Like when we'll find for this compound C double bond C. For cis and trans, it must at least one double bond. So it will be CH3, CH3, H, and H. In this case, it's called the cis Miss S propute 2 butene. From where we determine the two with longest carbon chain. This is the longest carbon chain. After the counting, it will be 1, 2, 3, and 4 carbon atom. 1, 2, 3, and 4. The double bond between the carbon atom number 2 and number 3. So we're taking the lowest numbering. So to 2 Miss S butene. Cis means that the carbon atom taking the shape of the magnet, O2 magnet. So we'll find the CH3 in this side and else in CH3 in this side. Okay, this is called cis2 butene. For the trans, it will be C double bond C, CH3. Then trans CH3, H, H. So in this case, we'll find the compound taking the shape of the magnet, but it taking the shape of the chair, of arrangement of the chair in the trans. This is called the trans 2 butene. What is the differ? They differ in arrangement of the atom at the two sides of the double bond. They differ in geometric structure, orientation of space, deviation of the light. So it is about the isomers, the two type of the isomers, constitutional isomers and the optical isomers. It is our lecture today. But before we end this session, so I apologize, it will be finished today early since I'm go to the hospital. So one of my colleagues that is affected by the heart attack, so I must leave after the moment to go to the hospital. Before this, are going to talk
ألف
about
سلامة يا
the
مستر.
ألف
peace be
سلامة يا
all
مستر.
of you. Thank you,
ألف
all of
سلامة.
you, thank you all of you.
ألف
Okay,
سلامة عليكم يا مستر.
Alliance. Thank you all of you. Okay, now this is the I'm saying it is the PowerPoint. This PowerPoint represents what we said before or said today. It's talking about the constitutional isomers of the alkanes. It's talking about the example, the N-butene and the isobutane. It is the normal isomers. And taking about the chiralic atom, and the molecule and its shape in the stereostructure, the arrangement of the chiralic atoms, and the different physical and chemical properties. It said that when I told you that the D-glucose are used to liberate the energy and metabolism inside your body, but the L-glucose and exerted outside the body, unused. And another type we will find the L-alanine is cooperating naturally in the protein, but D-alanine is not used. Sometimes we'll find when we'll find the chiralic atom, maybe use, not be unused. Okay, I'm apologize to all of you and must leave it now, inshallah.